Let's walk through the solution for Challenge 1, User Behavior File. This model filters the raw events table to prepare clean session-level data for funnel tracking. We've already created the file under Sales Funnel Report and named it 01 User Behavior.sqlx. At the top, we start with the config block. Here, we set the type to view, which means this model will be a virtual table. It won't store data physically. We give it the name User Behavior and tag it under Sales Funnel Report, so it's easy to group and deploy later. The description helps document what this model does inside Dataform. Now, let's go through the SQL logic. We're querying the events table using the ref function. That ensures proper lineage and dependency tracking inside the DAG. We select only the columns we care about for funnel analysis: user ID, session ID, traffic source, browser, event, type, and we cast created@ into a new column called event.Date. This gives us clean date-based events that we can join to orders or other models later on. Then we filter down to the 3 key event types that make up the funnel: page view, add to cart, and purchase. And finally, we exclude any rows where user ID is null, since we only want events tied to real users. That's it. This model is now ready to be used downstream as the base for our funnel. Everything's modular, clean, and reusable, exactly how we want to build in Dataform. Let's go through the solution for Challenge 2, Order Details SQL file. This model joins order items with orders to create enriched line-level sales data, the kind of output you'd use for KPI reporting or downstream joins. We start with the config block at the top. The type is set to view, so again, this won't store data physically. It's a virtual layer. We name the model Order Details, tag it under Sales Funnel Report, and describe exactly what this file does. Now onto the logic. In Step 1, we create a CTE called Base Items. This filters the order in items table to only include records where created is on or after June 1st, 2024. We select all the critical columns from that table: IDs, product, and user info pricing timestamps like created@, shipped@, delivered@, and returned@, and the status of each item. In Step 2, we clean the orders table. We select key metadata like order status creation, date delivery, and return info and number of items per order. We also rename a few fields to make our join cleaner. For example, status becomes order status, and created@ becomes order created@. Finally, in Step 3, we join the 2 CTEs using a left join on order-D. The final select gives us 1 row per item, enriched with order-level context, ready to be joined with product or user data later. It's clean, modular, and focused. Just one job per model. Let's walk through the solution for Challenge 3, User Segments SQL file. This model processes the raw users table to generate enriched user profiles, including segment labels based on age, gender, and acquisition channel. At the top, we've defined a standard config block. The model is a view named User Segments, tagged under Sales Funnel Report, and clearly described as a profile enrichment step. Now into the logic. In the first CTE, called Users Filtered, we're pulling records from the Users table using ref, always keeping lineage intact. We apply a simple filter here. Only include users created on or after June 1st, 2024. Then, we select the core user attributes: user ID, gender, age, traffic source, and the created@ timestamp. From that filtered base, we move into the final select. We cast the age field to an integer to make it clean for logic. Then we use a case statement to bucket users into age bands: 18 to 25, 26 to 35, 36 to 50, over 50, and unknown. If age doesn't match any band, the result is 1 row per user, enriched with demographic and acquisition metadata, ready to be joined to sessions, orders, or any behavioral models later in the funnel. Modular, readable, and scoped to do exactly one thing well. Let's walk through the solution for Challenge 4, Product DIM SQL file. This model builds a clean product dimension, combining core product attributes with distribution center metadata. We start with the config block. The model is defined as a view named Product Dim, tagged under Sales Funnel Report, and described clearly as product-level enrichment. Now into the logic. We pull from the products table and join it to the distribution centers table using distribution center ID. We use the ref function for both inputs, keeping the model linked in the DAG. From products, we select product ID name category brand, department retail price cost, and the foreign key to distribution center. From the join distribution centers table, we bring in distribution center name, latitude, and longitude. This gives us a full product dimension with everything we need to support sales reporting, segmentation, and geographic analysis. And with that, our blueprint blocks are done. Each model we have built, user behavior, orders, users, and products, is now ready to be joined together in the final summary. Let's walk through the final challenge, Sales Funnel Summary SQL file. This is where everything we've built comes together. We're joining all 4 of our modular models, user behavior, orders, products, and user segments, into a single funnel summary table. At the top, we define the config block. This time, the model type is set to table, which means it will physically store data in BigQuery. We're partitioning by event date, clustering by user ID and product ID, and giving it the name Sales Funnel Summary. It's also tagged under Sales Funnel Report, just like the rest of the models in this section. Now, let's walk through the SQL. We start from user behavior, our session-level event data. We left join to order details on user ID, then join to product dim using product ID, and finally to user segments on user ID again. For the select, we include all relevant fields from each model. From user behavior, user info, session ID, traffic source, browser, and event date. From user segments, age band and gender. From product dim, product ID, name, category, brand, department, and pricing. From order details, sale price, item and order status, returned flag, and 2 binary flags to capture user actions. Added to cart, when the event type is add to cart, purchased when the event type is purchase. This gives us a complete flattened funnel table, ready for reporting or further aggregation. Now before we move on, let's go to the lineage view. You should now see the full dependency graph with all 5 models connected. If you don't, or if your model doesn't compile, there's probably a syntax error somewhere. Fix that first, then come back and check the graph again. And finally, we'll trigger a run preview to compile everything. But we won't execute this model yet. We'll cover execution and deployment in a later section. For now, you've built a complete modular analytics pipeline, and you did it the right way: clean, reusable, and version controlled. Let's keep building.